The following data pertains to a tension test conducted in a laboratory. So pertains means collected. So given some tensile test data here. So let us see one by one. Diameter of the specimen. So diameter of the specimen is 15 mm, and length of the specimen is 200 mm, and extension under a load of 10 kilonewton is 0.035 mm. So extension of bar under load of 10 kilonewton is 0.035 mm. Load at yield point 110 kilonewton. Maximum load is 190 kilonewton. So load at yield point is 110 kilonewton, and maximum load is also known as ultimate load. So this load is the ultimate load. Okay. So length of the specimen after failure. So length of the specimen after tensile test. So what is the final length of the specimen? 255 mm. It's not meters actually, mm it. Meters kaadu. Okay na? 255 mm. Next, neck diameter. So here neck diameter how much is given? 12.25 mm. Neck diameter is 12.25 mm. So this is the data of this is the tensile test data. So finally what we need to find? Here we need to find Young's modulus. First of all, determine Young's modulus and ultimate yield stress and ultimate stress, percentage of elongation, percentage of reduction in area, and finally safe stress using a factor of safety of 1.5. So safe stress, so how do we get safe stress? So safe stress is equals to yield stress by factor of safety. So remember, safe stress is always calculated at yield point. So safe stress always calculated based on yield stress. Okay na? So what is generally yield point or yield stress? Okay na? The stress at which the body starts to elongate plastically. Okay na? So plastic deformation start అవుతుంది yield point నుంచి. Okay. సో అందుకే మనకి డిజైన్ చేసినప్పుడు సేఫ్ స్ట్రెస్ అనేది yield point స్ట్రెస్ దగ్గర క్యాలిక్యులేట్ చేస్తాం. ఓకే. Okay, first of all we need Young's modulus. So let us calculate Young's modulus. Okay. Young's modulus or modulus of elasticity. Young's modulus is also known as modulus of elasticity. So according to Huxley stress strain theory, Young's modulus is equal to stress by strain. Stress by strain. So stress denoted by sigma and strain denoted by epsilon e. Okay. And more generally, normal stress by normal strain. Young's modulus is equal to normal stress by normal strain. Okay. So to get Young's modulus, we need stress and we need strain. And remember, while calculating Young's modulus, we always consider longitudinal strain. That is strain experienced by the specimen in longitudinal direction, longitudinal strain. Okay. సో టెన్సైల్ స్ట్రెస్లో మనం ఎప్పుడైనా కూడా యంగ్స్ మోడల్స్ క్యాలిక్యులేట్ చేస్తే ఇప్పుడు కూడా ఏం తీసుకుంటాం మనం? స్ట్రెయిన్ ప్లస్ లాంగిట్యూడినల్ స్ట్రెయిన్ తీసుకుంటాం. ఓకే, రిమెంబర్. ఓకే, అండ్ వాట్ అబౌట్ నార్మల్ స్ట్రెస్? వాట్ ఈస్ ద ఫార్ములా ఫర్ నార్మల్ స్ట్రెస్? నార్మల్ స్ట్రెస్ ఎలా వస్తుంది? సిగ్మా ఎలా వస్తుంది? నార్మల్ స్ట్రెస్ ఈజ్ ఈక్వల్స్ టు resisting force by area. Resisting force generally called it as load by area. Simply we called it as load by area. Resisting force by area or simply load by area. So sigma is equal to load denoted by P and area denoted by capital A. And here load is how much? Load is already given. So the extension under a load of 10 kilonewton The extension under a load of 10 kilonewton is 0.035 mm. Here extension in the sense change in length delta L is given, and here load of how much load is given 10 kilonewton. So 10 kilonewton outundi P. So convert kilonewtons into Newton. Kilo means 10 cube, so 10 into 10 cube Newton per area. We generally conduct a tensile test on cylindrical specimens. We use cylindrical specimens for tensile test most commonly. So area of cylinder, here A means area of cylinder or area of specimen. So cylindrical shape means area of cylinder is pi by 4 into d square. Okay. So A is equal to pi by 4 into d square is equal to pi by 4 into, here d means diameter of the specimen. Here diameter of the specimen is 15 mm. So 15 square. Now sigma is equals to load how much, 10 into 10 cube Newton by, so area here 15 mm means 15 mm into 15 mm mm square, 15 square and mm square here. So sigma is equal to 10 into 10 cube by area pi by 4 into 15 square means how much, 225 mm square. Now sigma is equals to pi by 4 reciprocal, 4 by pi, 4 into 10 into 10 cube by pi into 225 mm square. Now stress is equals to normal stress, sigma is equal to, let us calculate value of this. Forty into divided by shift pi into 225, 56.588, 56.59 approximately 59 Newton per mm square. So here also units you will get Newton per mm square, Newton per mm square, stress unit Newton per mm square or MPa, 56.59. Now next we need strain. Strain is equals to longitudinal strain, change in length by original length, change in length by original length. So longitudinal strain తీసుకుంటాం, calculate చేస్తాం, change in length by original length, change in length by original length. Okay, so change in length by original length, delta L by L. You already given change in length, extension how much you given under load of 10 kilonewton. So here extension under load of 10 kilonewton is 0.035 mm. So change in length 0.035 mm, delta L mm by original length how much, length of the specimen is 200 mm. See, length of the specimen, original length 200 mm. Mm cancel. So 0.035 by 200, 0.035 divided by 200. So answer 1.75 into 10 to the power of minus 4. 1.75 into 10 to the power of minus 4. Okay. So we got stress is equals to 56.59 Newton per mm square or MPa. And strain has no units, remember. Strain is equal to 1.75 into 10 to the power minus 4. Now my Young's modulus E is equals to stress by strain. 56.59 by 1.75 into 10 to the power of minus 4 megapascals or Newton per mm square. E is equal to, so now calculate. 56.59 divided by 1.75 into 10 to the power of minus 4. So answer you will get 56.59 divided by 1.75 into 10 to the power of minus. You will get 371.42. 371.42 42 MPa megapascal. Okay, so or Young's modulus E is equal to, move this decimal point to 3 places, 1 2 3, so 323.37 into 10 cube megapascal. So we know that 10 cube megapascal is equal to 1 gigapascal. So E is equal to 323.37 gigapascal. Gigapascal. Okay, so this is the value of Young's modulus. Okay na, ila calculate cheyali. So next em kavali manaki, next we need yield stress find out cheyali. Yield stress. So yield stress denoted by sigma y. So yield stress is equals to, so what is the formula? Load at yield point, yield stress formula, load at yield point. So yield point is a point at which the specimen deforms plastically. ఓకేనా. సో ఈ లోడ్ దగ్గర ఏ పాయింట్ దగ్గర అయితే మనకి స్పెసిమన్ ప్లాస్టికల్గా డిఫార్మ్ అవుతుంది, అంటే రీగైన్ చేయదు మళ్ళీ షేప్. ఓకేనా. సో పర్మనెంట్ డిఫార్మేషన్ అయిపోతుంది ఆ పాయింట్ తర్వాత. సో ఆ పాయింట్ని ఏమంటాం? ఈల్డ్ పాయింట్ అంటాం. ఓకే, లోడ్ ఎట్ ఈల్డ్, స్ట్రెస్ అండ్ కర్వ్ మీద వస్తుంది. లోడ్ ఎట్ ఈల్డ్ పాయింట్ బై ఏరియా ఆఫ్ ది స్పెసిమన్, ఏరియా. సో సిగ్మా వై ఈజ్ ఈక్వల్ టు లోడ్ ఎట్ ఈల్డ్ పాయింట్. So load at yield point మనకి ఎంత ఇచ్చాడు, given in the data, tensile test data. Load at yield point is 110 kilonewton. So convert it into newtons. So 110 into 10 cube newtons by area. So area of the specimen pi by 4 into d square. Cylindrical shape కాబట్టి సో అక్కడ ఏరియా ఏం తీసుకుని pi by 4 into d square. Here d is equal to 15 mm, 15 square mm square. Now sigma y is equal to, so 110 into 10 cube, pi by 4 reciprocal అయితే 4 by pi into 225 Newton per mm square. Stress units Newton per mm square or MPa. Now sigma y is equal to, so let's calculate the value of yield stress. 110 into 10 cube. Okay, now here I got the value 622.47 Newton per mm square, or 622 approximately 5 MPa. Okay, now this is yield stress. So this yield stress is used to calculate safe stress. Safe stress మనం లాస్ట్లో క్యాలిక్యులేట్ చేయడానికి దీన్నే యూజ్ చేస్తాం. నెక్స్ట్ సి, నెక్స్ట్ we need ultimate stress. Ultimate stress క్యాలిక్యులేట్ చేయాలి. Ultimate stress denoted by sigma u. So ultimate stress formula ఏంటి? Ultimate stress is equals to maximum load by area, or ultimate load by area. So maximum load by area or ultimate load by area. Okay na, fine. So here how maximum load, how much given? Here maximum load is equal to 190 kilonewton. So therefore sigma u is equal to ultimate stress is equal to 190. So kilonewton, kilo means 10 cube into 10 cube newton by area as usual pi by 4 into d square. So 15 mm diameter, so 15 square mm square. So you will get 190 into 10 cube into, so reciprocal of pi by 4, 4 by 5, pi into 225 Newton per mm square. So sigma u is equal to, calculate this, (190) into E3 into 4. E3 means 10 power 3 divided by pi into 225. So I got 1075. So maximum stress, ultimate stress is equal to 1075.37 18 Newton per mm square, okay, or MPa, megapascal, okay. So this is ultimate stress value. Next D. Next what we need? Next we need to find percentage of elongation. Next we need percentage of elongation. So what is the formula for percentage of elongation? Percentage of elongation is equal to length after failure. Length after failure. Here length means length of the specimen. Length of the specimen after failure minus original length. Original length. Here original length means gauge length. Okay, na? By original length. By original length, okay, or gauge length. So percentage of elongation formula, length of the specimen after failure minus original length of the specimen by original length of the specimen. So into 100, we need percentage, so multiply with 100, okay. So first of all, length of the specimen after failure, LF, minus original length, LO, by original length, LO, into 100. This is exact formula. So what is the length of the specimen after failure? You given length of the specimen after failure, how much you given? So length of the specimen after failure is 255 mm. So 255 mm, 255 minus original length. So original length how much? I think 200 mm given. So see, length of the specimen is, or okay, na, gauge length. Length of the specimen means original length or gauge length. How much? 200 mm. So before fail, initial length of the specimen, okay, before conducting tensile test, what is the initial length of the specimen? 200 by 200 original length. Yes. So 250 into 100. So 255 minus 200, 55. 55 by 200 into 100. 100 ones, 100 twos. 55 by 2. 55 by 2 means 27.5 percentage. 27.5 percentage. This is percentage of elongation. Okay. Need percentage of reduction in area. Percentage of reduction in area. Percentage of reduction in area. So is equal to formula initial area minus neck area by initial area or original area, initial area or original area into 100. So initial area also you can take original area here. So area of the specimen before conducting tensile test, original area, okay. So initial area means neck area by initial area into 100. So it can be written as initial area means original area, initial area EI minus neck area EN by initial area EI into 100. Okay, so here EI is equal to initial area pi by 4 into d square. Here diameter how much is given? 15 square, and neck area AN is equal to pi by 4 into dn square. Here dn square means neck diameter. You given already neck diameter. How much you given in the tensile test? I mean in tensile test data given neck diameter 12.25 mm. Neck diameter 12.25 whole square. Now substitute these two here. So percentage of reduction in area is equal to initial area pi by 4 into 15 square. Neck area pi by 4 into 12.25 whole square by initial area pi by 4 into 15 square into 100. So here pi by 4 common, take out pi by 4. So you will have 15 square minus 12.25 whole square by pi by 4 15 square. Pi by 4 cancel into 100. Okay now. So let us calculate the value of 15 square minus 12.25 square by 15 square into 100. So let us calculate this value. ఈ value find out చేద్దాం. So 15 square minus 12.25 square by 15 square. So I got 0.33305 into 100. Into 100 you will get 33.305 percentage. So 33.3% approximately. This is percentage of reduction in area. Percentage of reduction in area is 33.305 percentage. So at last we need safe stress. So last ఏమి ఇచ్చాడు మనకి, లాస్ట్ క్వశ్చన్ ఏం కావాలి, F safe stress. Safe stress denoted by sigma safe, sigma suffix safe. Safe stress always calculated at yield stress. Yield stress there calculate చేస్తాం because yield point is a point where that material or specimen under tensile test is begin to deform plastically, begins to deform plastically. సో ఆ పాయింట్ దగ్గర, ఆ పాయింట్ తర్వాత మన స్పెసిమెన్ అనేది ఏమవుతుంది, ప్లాస్టికల్గా డిఫార్మ్ అయిపోతుంది. ఓకేనా, ఇట్ మే నాట్ రిగైన్ ఇట్స్ ఒరిజినల్ షేప్. ఒరిజినల్ షేప్కి రాదు లోడ్ రిమూవ్ చేస్తున్నా. ఓకేనా, సో అందుకే మనం ఎక్కడ క్యాలిక్యులేట్ చేస్తాం సేఫ్ స్ట్రెస్ ఇప్పుడు కూడా ఈల్డ్ పాయింట్. సో సేఫ్ స్ట్రెస్ ఈజ్ ఈక్వల్ టు ఈల్డ్ స్ట్రెస్ బై ఫ్యాక్టర్ ఆఫ్ సేఫ్టీ. ఈల్డ్ స్ట్రెస్ బై ఫ్యాక్టర్ ఆఫ్ సేఫ్టీ. దిస్ ఈస్ ద ఫార్ములా ఫర్ సేఫ్ స్ట్రెస్. సేఫ్ స్ట్రెస్ ఈజ్ ఈక్వల్ టు ఈల్డ్ స్ట్రెస్ బై ఫ్యాక్టర్ ఆఫ్ సేఫ్టీ. సో సేఫ్ స్ట్రెస్ ఈజ్ స్ట్రెస్ క్యాలిక్యులేటెడ్ అట్ ఈల్డ్ పాయింట్. ఈల్డ్ పాయింట్ దగ్గర డెవలప్ అయిన స్ట్రెస్ ఇది. సో ఎనీహో ఈల్డ్ స్ట్రెస్ మనకి ఎంత వచ్చింది, సిగ్మా వై బై ఫ్యాక్టర్ ఆఫ్ సేఫ్టీ. సేఫ్ స్ట్రెస్ సిగ్మా సేఫ్. సో ఈల్డ్ స్ట్రెస్ మనకి 622.47 MPa or Newton per meter square by given factor of safety as 1.5. Calculate this. You will get sigma safe stress. Safe stress. సో ఎంత స్ట్రెస్ మనం అప్లై చేయొచ్చు అంటే, ఈ స్ట్రెస్ అప్లై చేస్తే మనకు మెటీరియల్ ఇంతవరకు మనకు ఆ మెటీరియల్ ఫెయిల్యూర్ అనేది అవ్వదు, సేఫ్ స్ట్రెస్. ఓకే, లెట్ us calculate. 622.47 divided by 1.5. So my safe stress is 414.98. 414.98 MPa megapascal or approximately 415 megapascal. 415 megapascal. 415 megapascal is the safe stress. Okay na? So this is the procedure to find values of procedure to find different parameters of tensile test. Okay.